Hey everybody, this is Larry, this is April 16. Hey, 4 square day, right? Hit the like button, hit the subscribe button, join me on Discord. We're doing April Leetcode Daily Challenge. Today's problem is remove all adjacent duplicates in string 2. So I usually solve this live, it's a little bit slow, fast forward to X or watch another video, I guess. But yeah, okay, given the string S, K duplicate removal consists of choosing K characters and then removing them. Okay, and can carry them at the end. Okay. Okay. It's guaranteed that the answer is unique. So in that case, I think so. The thing that I'm trying to think is whether, yeah, I mean, this is a tricky question in the sense that I'm trying to think whether you can mess up by greedy, because that's my first intuition, is just by greedy, and whether you can mess up by choosing greedy. I don't know. I know that there is a guarantee that the answer is unique, but yeah, I don't know. But yeah, so let's play around with greedy. Maybe this is a little bit YOLO. I'm trying to convince myself that it is good enough. To be honest, but otherwise, this is just going to be the way that they explain the problem is just going to be a stack. So you just implement a stack. You keep on pushing things up, and then when the character that comes in has, K count, we just remove it, and then we keep on doing it. And yeah, I mean, this is relatively straightforward in that sense. So let's just get start to do it. And in a YOLO situation, I might have done it like in a contest or something like that. But and something a little bit meta is that if I was in a contest, it depends on the difficulty as well. If this was a easy or maybe even a easier medium, I'll just be like, oh, it's probably greedy, and then just worry about the proof a little bit later. But yeah. So so what do we want to put on the stack, right? We want to put on the stack a tuple, two things. Say xy, where x is equal to the character and y is equal to the number of overlap. So that this way we don't have to pop like k times to see if it's at the same time. We just do it one at a time. So here we look at if this is not equal to x, then x1. Otherwise x is equal to the top of the stack. Oh, should be 0. Oops. And in that case, we want to, top is equal to stack.pop. And we just want to push in that, but increment the number of count, right? Top 0, top 1 plus 1. So that's basically the idea, but we're not done yet, of course. Now we have to do, now we have to remove the ones where there's k in a row. And of course, there's only one place that would happen, because if you look at this, well, except with this, I guess, because I guess k could be equal to 1, though that's, no, k cannot be equal to 1. But if k is equal to 1, then you have to keep that in mind. But the only place where k can be reached by this number, it's here, right? So then we can just check this here. If top is equal to k, and maybe I would use the walrus symbol here, but maybe we don't need it, just to make it more readable. I think to give it a variable to this thing. You could also use a name tuple to kind of make things more readable instead the way that I did, which I actually usually recommend if you're doing production code or something like that. But yeah. So if the top is equal to k, then what do? Oh yeah, then we just pop. Oops, no. And this is not, I think I got a little confused. This is the stack. Okay. Yeah. And the reason why you only do it once is because that's the only thing that changed, right? That's the only state that changed, and that's where you kind of do the invariant on what does the loop invariant means, right? And it can further compress, but it requires new characters to come in because you cannot eliminate two things at the same time, given that we don't look at the characters from the right yet. And then at the very end, stack is going to contain the thing. Oh no, I was going to just join it, but at the very end, we just go from the looking at the stack from the beginning to the end and just add everything together. So yeah, so so for x, y in stack, we do x times y, I think. And that's probably close to it. Let's give it a look. I mean, maybe there's some like typos or something, of course, but oopsie daisies. But yeah, usually you know that I look at the running time and stuff, or I look at constraints a little bit more. But for this problem, and actually it wasn't intentional that I skip it in terms of explanation, but I did skip it because when I knew it was greedy and when I thought about it being a stack, yay, I knew it was going to be linear time, linear space, and usually you cannot do better than linear time, linear space. There are a few cases where that is not fast enough, but this is good enough. So yeah, linear time, linear space. So then I was like, oh, I don't have to worry about the performance because unless I'm doing something crazy in the linear space or linear time, it's okay. And in this case, it is. So yeah. So what is the complex? As I said, because we have we just look at each character at most once, so that's going to be linear time because we only do all these operations are all of one. In terms of space, well, we don't have a stack, so that's also going to be linear space. So yeah, linear time, linear space. Let me know what you think. Hit the like button, hit the subscribe button, join me on Discord. So I am a little bit got some sniffles. I don't know why, but yeah, I'll see you tomorrow. Take care and to good mental health. Bye bye.